Okay, so now we're good to go. Uh, so let's do this first example here. And in this first example, it says to find all the solutions of the equation that's in the interval from 0 to 2 pi. Now, one of the things that you need to notice about this is the 0 is included, but the 2 pi is not. So we're going from 0 to 2 pi with 2 pi not being part of the answer. So that's something to be careful about. Here's the process on how to solve this problem. So I'm going to rewrite the problem. So I'm going to get 3 cosine theta minus 1 is equal to a negative 1. Now what I'm going to do is I'm going to add 1 to each side, right? It's just like algebra, actually. So it's going to be 3 cosine of theta is equal to 0. Then I'm going to divide by 3. So I'm going to get cosine of theta is equal to 0 over 3. And then we see that we're going to get cosine of theta is equal to 0. Well, where is cosine of theta equal to 0? If we look at the unit circle, right, something that you guys should have, one of the things that's important is it's the cosine represents the x-coordinate. And so up here, we're going to get 0, 1. And down here, we're going to get 0, negative 1. Well, we want our answer in this problem to be in terms of pi. So that tells us that theta then needs to be equal to pi over 2 or 3 pi over 2. And the reason we only have two answers, we're not going to do the plus k pi, is because we're in that restricted domain from 0 to 2 pi. Is that okay? Okay, cool. All right, let's look at number 2. Again, we have that restriction. We're going to solve it just like we've done in the past. So 2 sine of theta minus radical 2 is equal to 0. I'm going to add radical 2 to both sides. So that's going to give me 2 sine theta is equal to radical 2. And then dividing by 2, I'm going to get radical 2 over 2. And now where is sine? A positive. So we're going to look at the unit circle again. And we're looking at where it's that's a terrible circle. Let me erase that. It's not too much better, but that's okay. Here is where it's positive, and here is where it's positive, correct? So that occurs at pi over 4, and it occurs at 3 pi over 4. So my theta in this case is going to be pi over 4 and 3 pi over 4. So you can see this is pretty straightforward. It's really not too bad. But let's go ahead and continue to practice because I want to make sure that you guys fully understand these. Okay. Number 3. So here we're going to get, we're going to get secant theta, and I'm just going to add the 2 to the other side. So I'm going to get secant theta is equal to 2. One of the things that we need to remember is that secant theta is the same as 1 over cosine theta. So 1 over cosine theta is equal to 2. So what that is, it's the same as cosine of theta is equal to 1/2. Does that make sense to everybody? How I got that to become cosine of 1/2? If there's anyone that doesn't, I can definitely show you. But I just want to make sure that you guys understand that algebra that's there. Okay, so then from there, again, looking at the unit circle, we're in the positive 1/2, correct? So that means it's going to occur here and here because cosine deals with x, so it's the x coordinate, so it has to be to the right of the y-axis. And that occurs at pi over 3 and at 5 pi over 3. And again, it's because of our domain restriction. My theta is going to be pi over 3, comma, 5 pi over 3. Okay, do you guys want to try to do number 5 real quick, and then I'll do it? See if you guys can get the same answers as me. All right, I'll give you guys about a minute, okay? All right, let's see if you guys got what I got. So I'm just going to go, all right, it's tangent of theta, and it's equal to a negative radical 3. So remember, one of the important things too with this is all students take calculus. So we know that tangent is positive in quadrants 1 and 3. So to get a negative, we'd have to be in the second and fourth quadrant. And so this is where it's going to occur. And right here and right here. And so theta is going to be 2 pi over 3 and 5 pi over 3. Clean that up. Were you guys able to get that? Okay. Well, for those of you who don't worry. You're going to refer to the unit circle. But one of the things you got to remember too is tangent of theta is equal to sine of theta over cosine of theta, or we can think of it as y over x. So with that radical 3 there, it should be, the y should be negative radical 3 over 2, and x should be 1/2. And then, that's for quadrant 4, and then for quadrant 2, it should have been radical 3 over 2 over a negative 1/2. So that's how we get our negative sign that's in this problem. Does that make sense to everybody? I just want to make sure that that's being communicated clearly to you. All right. I've got 2 people who got it. All right, here's number 6. So let's go ahead and do this. And again, we're being restricted. So, oops. Now here, in order to solve this, because negative 3 over 7 isn't something that is very easy for us to find. And so what we're going to do is I'm going to use some trig inverse on this. So if I have cosine of theta is equal to a negative 3 over 7, this isn't one that I know. So what I'm going to do is I'm going to multiply both sides by cosine inverse. So I'm going to get theta is equal to cosine inverse of a negative 3 over 7, right? So what that does for me is it tells me something about the quadrant that I'm in. So remember, when we're talking about cosine of a negative 3 over 7, that's putting me in quadrants 1 and quadrants 2 and 3. So if we look at it, I'm going to attack it as a triangle. And so there's my -3, and then this radius is 7. Does that make sense? So I'm getting 7 here, and this is -3. So we can find that next angle. But one of the things in this problem is, and it's important for you to get this, is they want us to use a calculator. So we can do it that way, and I'll show you how to do that right now. But I wanted to show you what quadrants we're in. So we're here, and then the other triangle that we have would be down here. So these are two separate triangles. Does that make sense to everybody? Just want to be clear that you guys get that. All right, now this is where you're going to need your TI. If you have a TI or the calculator, the trigonometric calculator on the ALEX program. To do this, you're going to have to make sure that your mode is in radian. That's important. So your calculator will need to be in radian. And to do that on a TI-84, you just press mode, and you'll see it says radian or degree. Just make sure that it's highlighted on radian. And then what you're going to do is you're going to find this first angle. So this is the one we're going to find first. So to do that, we're going to type in literally this into the calculator. So to do that, I'm going to go second cosine of just cosine, and then I'm going to type in a -3/7. Just write it all as one piece. Okay, so when you do that, second cosine, and then a -3 divided by 7, I'm going to get an answer of 2.013707371. Were you guys able to get that on your calculator? Ooh, and my apologies. I didn't get that one. I actually went and got this one first. We're going to always be finding the larger one first. It says syntax error. Okay. First thing you have to do is make sure that your calculator is in radian. So are you using a TI-84, Zara? TI-10. Okay, make sure that you get your calculator to be in radian, because or else you will get a error. Because right now you're in degrees. Maybe look that up on YouTube to be able to find that. Or if you need my help, I can try to help you find that later. Okay, so this is one of the answers. To find the other answer, and I'll do it in red, to find this answer here, what we're going to do is we're going to take this answer that we got, and we're going to go 2 pi minus the answer that we just got. Okay, so this we'll call theta 1, and this one we'll call theta 2, because it's the bigger of the two. Now with your calculator, you'll go 2 pi minus the answer that you got, and you should get 4.27 radians. Ooh, I'm silly. I had it right the first time. This is pi over 2, and this is 1. So I have them switched. Ah, silly me. My apologies. So blue is this one, and red is this one. So we're going after the small one first and then getting the second one. My apologies. I don't want to confuse you guys. So the angle for this one is this, and the angle for this one is just to here. We'll do some more practice. I just want to make sure you guys are okay. Okay, let's do the next one. So again, we're going to find the first angle and then get the second angle. So when they're in the second and third quadrant like that, the way we're doing it is we're basically subtracting the full circle from the first angle. Does that make sense? So that you end up at quadrant 2. In this next example that we're going to do, it's going to be slightly different because we're in different quadrants. So let me show that to you guys so you guys can see that. So in this case, we're going to end up with cotangent of 2 over 3 is the same as 1 over tangent theta of 2 over 3, right? So then that's going to become tangent theta of 3 pi over 2. And so since it's positive, that tells us that we're in quadrants 1 or 3. And so when we look at our circle, we're going to end up either here or down here. And so here what we're going to do, and I'll explain this to you guys, the first angle is going to be this one, and then our second angle is going to go all the way through. Okay, does that make sense? The two angles? Okay, cool. Now from here, to get the first angle, and again we're dealing in radians, it's important. So my first angle, and I'll do it in blue just so I'm color coordinating for you guys. I'm going to go theta of 1 is going to be equal to, now it's the inverse, right? The inverse of that thing, and then when we plug that into the calculator, because they want it in the hundredths, we're going to deal in just the hundredths. So this one would have been just to that 1. So I'm going to go tangent inverse of 3 divided by 2, and that's going to give me my theta angle of 0.9827. So that means my angle should be this. Okay? Now, something interesting. Because this is a straight line, to get to this point from here, isn't that just half of a circle rotation? Right? Since it's half of a circle rotation, isn't that just going to be adding pi? So since I'm just going to be adding pi, to get the second angle, what I'm going to do is I'm going to go theta of 2 is equal to theta of 1 plus a half circle rotation. So then that's going to give me 0.9827 plus pi, and that should give me 4.124. And again, these are radians. I should write that down. This is radians. But since I only want it in the hundredths place, I should get 4.12 because the 4 isn't going to have me not round up. It's going to have me stay the same, correct? Are there any questions on these two? Okay. If anyone does have questions, please I have you guys where you can activate your mics and ask questions if need be, okay? Because I do want you guys to be able to talk to me if needed. Okay, so notice this one. Is there a restriction on our interval? Since there's not a restriction here, we're going to have to add multiple answers, okay? So if we look at this, when is sine of theta -1? Well, if I look at a unit circle, and I'll just draw a little one. Here's the unit circle. Isn't that right there? And doesn't that occur at 3 pi over 2? So I know that my theta is going to be 3 pi over 2. But since I'm not limited, isn't every full circle loop around that going to end up in that same spot? Does that make sense what I'm saying to you guys? So if I were to go, okay, from here I'm going to go a full circle around. Well, where did I end up? At the same spot. But I'm actually 2 pi bigger than 3 pi over 2. And then if I did it again and went all the way around again, wouldn't I also be at the same spot, but 2 pi bigger? So when I write my answer for this, I'm actually going to be able to go plus 2 pi times some k integer, where k is a positive or negative integer. So, well, being an integer can be positive or negative, because I can also go a negative 2 pi going the other way, right? Because I can go counterclockwise and clockwise and still end up in the same spot. Does that make sense to everybody? Okay, cool. Now it's important that you remember k is it's an integer here. So that means that k is equal to plus or minus 1, plus or minus 2, and so forth and so on. Okay, so how many answers do we really have here? Isn't it infinite? Okay. For the next one, I'm going to get secant theta is equal to a negative radical 2. That's the same as 1 over cosine of theta equals to a negative radical 2. And that would be the same as cosine of theta is equal to a negative radical 2 over 2. So where does that happen? So if I already look at my unit circle again, we need it to be negative, so that should occur here and here. And so for this guy right here, isn't that 3 pi over 4? So I'll call that my theta 1. But again, I can rotate around full circles, correct? And since I can rotate around full circles, I'll do that in black this time. It's going to be 2 pi over k, or 2 pi k. That's one answer. Okay. And this one here, that's going to occur at theta 2 is going to be 5 pi over 4. And then again, plus 2 pi k, because we can do full circles to get to it. All right. We okay with that? Yeah. And this one, it's because we have two possibilities on the answers, and we can do full circles. So since we can have that, we have to two different angles because in order to add the full circle rotations, we need to do it that way. Okay, now let's look at number 12. So with number 12 then, we're going to get cosecant of theta is equal to 1. That's the same as 1 over sine theta, which is equal to 1. So sine of theta is equal to 1. So where is sine of theta equal to 1? You guys should start having these memorized, right? It happens at pi over 2. And again, since there's no restriction, we're going to get theta is equal to pi over 2 plus 2 pi k. And there's only one solution formula for this because it only happens at one place on the circle. Is that clear to you guys? Okay, yeah, good. Thank you. Thank you for replying. It's so strange to be here in my office at home. Okay, so now we have a problem again with some restrictions. And we have factors. So it's important that we look at these factors, okay? So I'm going to look, there's a rule in algebra that says that if you have a times b equal to 0, a is equal to 0, or b is equal to 0, or both are equal to 0, right? But by solving for each one, we can do it that way. So this is exactly how we're going to solve this problem. So I'm going to look at, all right, cosine of x plus 3 is equal to 0, and 2 sine of x plus radical 2 is equal to 0. And this is a 3. I just want to make sure that's a 3. So then cosine of x is equal to a negative 3. Well, on the unit circle, when is cosine of x ever equal to a negative 3? What do you guys think? On the unit circle, how big is the radius? Anybody? Yeah, it's 1. And so the biggest value that cosine can be in the unit circle is plus or minus 1. So this is too big, so this is not a possibility, right? That can't happen. Not in our unit circle. Now on the other side, I'm going to get 2 sine of x is equal to a negative radical 2, and then sine of x is equal to a negative radical 2 over 2. Where does that happen? So again, if we look at the unit circle, we see that that's going to happen here, and that's at 5 pi over 4, and at 7 pi over 4, correct? And so my x is going to be 5 pi over 4 or 7 pi over 4. All right. Do you guys have any questions on that? Okay. Okay. All right, so here's 14, and again, we went back to some restrictions, and we have 2 factors, right? So we're going to do it, so all right, we have sine of x is equal to 0, and 2 cosine of x minus 1 is equal to 0. Well, where is sine of x equal to 0? Well, if I look at the unit circle, I know it's going to happen here and here. So my x in this case is going to be 0 or pi. And then over here, I'm going to get 2 cosine of x is equal to 1. Cosine of x is equal to 1/2. And now I need to find out where that happens. So I'm going to again look at the unit circle. And I see that it's going to happen here and here. And that's pi over 3 and 5 pi over 3. And so we can see that our answer in this problem is 4 possibilities, right? So it's either x is 0, pi over 3, or 5 pi over 3. So it's important that when we look at this and we do these factoring pieces, that we do see that there's potential for many, many answers, okay? All right, in our next example, we don't want to do things in terms of squares, so we want to simplify. So we're going to get cosecant, squared minus 2 is equal to 0. So I'm going to get cosecant squared of x is equal to 2. Then getting rid of the square by taking the square root, I have to have plus or minus 2. So now what this is telling me is that there's 2 possibilities to solutions, a positive case and a negative case. And so in the first case, I'm going to use the positive case. I'm going to get 1 over sine of x is equal to radical 2. So then sine of x is going to be equal to radical 2 over 2. Right? And we know from the unit circle that that's going to occur at pi over 4 and 3 pi over 4. And then for the other case, the negative case, it's going to be the same situation. Sine of x is equal to a negative radical 2. So then sine of x is going to be equal to negative radical 2 over 2, and that's going to occur at 5 pi over 4 and 7 pi over 4. Okay, does that make sense? So just on the unit circle so we can show it. The positive cases are going to occur up here, right? Because sine is positive, it has a positive value of radical 2 over 2 in the first and second quadrants. That's my pi over 4. That's my 3 pi over 4. And then it's negative down here, and that's where I get my 5 pi over 4 and 7 pi over 4. We okay with that? The trick to this problem, though, is to make sure that you get rid of the square, and then remembering that when you get rid of a square, you have the plus or minus case, so you have to deal with both cases. Are we okay with that? Okay, cool. Just trying to make sure that you guys get the complexity of these problems, because they are a bit complex. One thing I do want to encourage you guys on as we are doing this, I know last week was spring break, but the best way to be learning this material, even probably better than the lecture, is to be doing your work on Alex. It's important, and so please continue to get on that. Yeah, it's important. And so today, you have that quiz that we're going to be doing. Please make sure to get on there, but also I encourage you guys to get some of that, get your modular work done, your homework, because I really think that all of you can pass this class, so just keep working, all right? Just a little bit of encouragement. Okay, so with this problem, we're going to go through the same phases. So 2 sine squared theta is equal to 1, then sine squared theta is equal to 1 over 2. And then when we take the square away by square rooting, I'm going to get plus or minus the square root of 1 over 2. And so that's going to give me 2 cases, correct? So I'm going to get sine of theta with the positive case is going to be radical 2 over 2. And the negative case is going to be a negative radical 2 over 2. And so looking at our unit circle, we see that's going to occur at pi over 4 and 3 pi over 4. And this one's going to occur at 5 pi over 4 and 7 pi over 4. Does that make sense? Okay. I don't want to go too fast for you guys, so I'm trying to base it off of how you guys are responding. So just wanted to make sure that you guys are okay. All right. Okay, so then 17. Now 17 is a bit tricky, and I want to show you. So see sine and sine. Let's just call it the red part. I'm going to call x, just so you guys can see it a different way. So what if I went like this? Couldn't we factor that thing? Right? That becomes something that's factorable. And so that's 2x and x, and then 1 and 1, and this one's minus, and this is positive. Right? Now, what I'm going to do is I'm going to switch it back. So I'm going to get 2 sine of x plus 1 sine of x minus 1 is equal to 0. And so now I've put this problem so it looks like the problems we just did. Okay, so 2 sine of x plus 1 is equal to 0. And sine of x minus 1 is equal to 0. So the crux here is to be able to factor. So then here I'm going to get 2 sine of x is equal to a negative 1. Sine of x is equal to a negative 1/2. Where does that happen? You can look at your unit circle. It happens at 7 pi over 6 and 11 pi over 6. So that should happen in the third and fourth quadrant because sine is in terms of y, so you should be below the x-axis. My other one over here, I'm going to get sine of x is equal to 1. Where does that happen? And that happens at pi over 2. Okay, so any questions on how I did the factoring there? How I did my substitution? Some of you won't need to do the substitution if you see it, but sometimes I like to do the substitution because it makes it look cleaner for me. You guys okay with that? Okay. Okay. All right. So then let's look at this one. And again, here it's cosine and cosine. So since it's cosine and cosine, I'm going to go, all right, that's 2x squared plus 7x minus 4 is equal to 0. And that gives me 2x and x and that looks like 4 and 1, so I should get plus and minus. So now I know what the factors are, so I'm going to get 2 cosine of x minus 1 and cosine of x plus 4, and that's supposed to be equal to 0. So then setting each one equal to 0, I'm going to get 2 cosine of x minus 1 is equal to 0, and cosine of x plus 4 is equal to 0. So then here, 2 cosine of x is equal to 1, cosine of x is equal to 1/2, and that occurs in 2 positions, so x is equal to pi over 3 and 5 pi over 3, and again we have restriction, so those are the only ones we have. Now here I get cosine of x is equal to -4. Is that possible? You're right, that is not possible, so that's going to be eliminated. Okay, in our next example, we need to do some manipulation. So if you look here, this is cotangent, but the next one isn't cotangent, it's cosecant. So that means I need to know my identities. So my identity tells me that cotangent squared theta is equal to cosecant squared theta minus 1. So instead of cotangent squared theta, I'm going to change it to cosecant squared theta minus 1 so that everything is in terms of cosecant. Does that make sense to you guys? So when I write this, I'm going to go, all right, cosecant squared theta minus 1 minus 2 cosecant theta is equal to -1. Now what I'm going to do is I'm going to add 1 to both sides. So I'm going to get cosecant squared theta minus 2 cosecant theta is equal to 0, right? So then from here I can factor out a cosecant. So I'm going to get cosecant theta minus 2. And now I have my 2 factors for this. And so cosecant of theta is equal to 0, and cosecant of theta minus 2 is equal to 0. Well, this is 1 over sine theta is equal to 0. Can that ever happen? Will that ever be 0? The answer here is never. That cannot happen, because since we only have sine in the denominator, it's impossible for us to get 0, because that would make this thing undefined in the denominator. It cannot happen. Now on the other side, we're getting cosecant theta is equal to 2. Well, isn't that the same as 1 over sine theta is equal to 2? Or that sine theta is equal to 1/2. Well, where does that happen? It happens in 2 places. Theta would happen at pi over 6 or 5 pi over 6. Okay? Are there any questions on this problem at all? It's all about knowing the identities, right? We have these identities here that are going to be so important. That's one of them. Remember, we had sine squared theta plus cosine squared theta is equal to 1. And then for tangent, it was tangent squared theta plus 1 is equal to secant squared theta. those are the three that you need to have really known and memorized. They're going to be useful. You'll use them again a lot. Well, you'll use them in pre-calculus, but you'll also use them when you get to calculus 2, which is called trig-based calculus. So it's important that you guys know this trigonometric stuff. Okay. Here's number 20. I feel like we're flying, but okay. All right, so to find this solution here is everything in terms of sine here. The answer is no, right? We have sine squared and we have something with cosine in it. So what we always do with this problem, just so you guys know, we change the squared term. So I'm going to change the squared term. And remember, I just wrote it. So sine squared plus cosine squared x is equal to 1. And so I know that sine squared of x is equal to 1 minus cosine squared of x. So I'm going to rewrite this thing in terms of that. So I'm going to go 2 times 1 minus cosine squared of x is equal to 2 plus cosine of x. Do you guys all follow that? This really is sine squared. Do you guys agree with that? Okay, cool. Just making sure you guys agree with that. So then I'm going to distribute, so I'm going to get 2 minus 2 cosine squared of x is equal to 2 plus cosine of x. And now what I want to do is I want to move everything, but I want to move it in a way that it becomes positive. So I'm going to move this stuff that way. So this is going to become 0 is equal to 2 cosine squared of x plus cosine of x. And then the 2's are going to cancel each other, correct? Okay, so then I can factor out a cosine. So I'm going to get cosine of x and then times 2 cosine of x plus 1. And now I have the 2 factors that I can set equal to 0. So I'm going to get, all right, cosine of x is equal to 0. And when does that happen? Cosine of x is equal to 0 at pi over 2 and 3 pi over 2. And then over here, I'm getting 2 cosine of x plus 1 is equal to 0. So 2 cosine of x is equal to a negative 1. So cosine of x is equal to a negative 1/2. So we see here that x is equal to 2 pi over 3 and 4 pi over 3. So again, in this problem, we have 4 solutions. That's something for you guys to know. And again, the reason that is because we are restricted by our domain. Are there any questions on this problem? Are you guys getting the flow of what's going on with these problems? Okay. I just don't want to put too much pressure on you guys. Now, one of the things, do you guys want me to finish all the notes today? And then on Thursday, what we can do is just do like homework questions and things like that? Or do you want me to stop and finish it on Thursday? However you guys want me to do it, I just want to be as accommodating to you guys as I can be. since I'm recording it, you guys can rewatch it as you go, but I just want your opinion or your thoughts on this at least. Okay, well, I just say let's keep going, and then on Thursday we can do question and answer. But what I'll do is I'll just keep the pace that I had from the syllabus in terms of quizzes and whatnot. Okay. All right. So here's the next one. So for this one then, now we have a different situation. We don't have squared terms, but we do have a cosine of 2x. And so we need to know what that identity is, right? So the identity for cosine of 2x to be in terms of sine, isn't that 1 minus 2 sine squared of x? Right? So it's important that when you guys do these problems, you guys go back to note 7 and get all those identities and write them down so that they're easily accessible for you, okay? Because or else you're going to be looking at these problems and you wouldn't know that cosine of 2x can be changed to something in terms of sine. Okay, so then this is going to be a negative 2 sine of x plus 1 minus 2 sine squared of x is equal to 1. And then what I'm going to do is I'm going to move things so that it's nice and clean for me. So I'm going to get 0 is equal to 2 sine squared of x plus 2 sine of x. And then the 1's are going to cancel each other out. I can get rid of the 2 also by dividing by 2. So I can clean that up and get, well, I'll do it this way. 0 is equal to 2 sine of x. Then I'm going to get sine of x plus 1. And so those are my two factors. So I'm going to get 2 sine of x is equal to 0. And sine of x plus 1 is equal to 0. Now from here, when is sine of x equal to 0, right? Because I divide by the 2. I know that that's going to occur at 2 places. So x is going to be 0 or pi. In this case over here, sine of x is equal to a negative 1. And that occurs only at one place, and that is at 3 pi over 2. And so we have these 3 solutions. Are we okay with that? Okay. Now, in this case, now we have sine of 2x, and so we have an identity for that. So I'll write that down for you. So then sine of 2x is equal to 2 sine of x, 2 sine of x times cosine of x, correct? So since we have this, I can rewrite it and put it in. So I'm going to get 2 sine of x cosine of x plus 2 cosine of x is equal to 0. So I can pull out a 2 cosine of x. And so I'm going to get sine of x plus 1 is equal to 0. And now I have my two factors for this. So 2 cosine of x is equal to 0. And sine of x plus 1 is equal to 0. Right? Again, going to that product of 0 property. So then cosine of x is equal to 0. So where does that happen? That happens at two places. It happens at pi over 2 and 3 pi over 2. And then here again, sine of x is equal to -1. We know that. We're starting to see it's repeating itself quite a bit. You guys feeling okay? I don't want to be rushing you, so please let me know. I want you guys to be as comfortable as possible. Okay? All right. So the next one. So in this next one, do I need to make changes? Can I factor this? The answer is no, because cosine of 2x doesn't have cosine of x. They have different angles. So again, I'm going to have to use a rule for this. And there's a rule that makes it turn into cosine. So cosine of 2x is also equal to 2 cosine squared of x minus 1. So it's important, right? Knowing these rules makes it very helpful for us. So then I'm going to substitute that in. And I'm going to get 2 cosine squared of x minus 1 is equal to 0. And then I'm going to rewrite it so it's clean. And then again, we're going to try to factor this. And so we're in terms of cosine, so I could change that to an x or something like that so you guys can see it. And please feel free to do that if you'd like. So that would be the same as 2x squared minus x minus 1 is equal to 0. And then you could factor that. I'll just factor it. So now here I have my two factors. So then 2 cosine of x plus 1 is equal to 0. And cosine of x minus 1 is equal to 0. So solving the one on the left, I'm going to get 2 cosine of x is equal to a -1. Cosine of x is equal to a -1/2. Where does that occur? So that has to happen in the second and third quadrant. So my angle is going to be 2 pi over 3 and 4 pi over 3. This one, I'm going to get cosine of x is equal to 1. When is cosine of x equal to 1? That only happens at 0, right? And the reason, again, it's not 2 pi and 4 pi and 6 pi is because we are restricted by our domain. Okay? Now, so far, the ones that we've done of these have all been restricted. This next one, number 26, you can see we don't have a restriction. So that becomes kind of a big deal. Okay? So that means we are going to have the plus 2 pi k or plus pi k. So this thing's already in the same form, so we can factor this. So cosine squared of x plus 4 cosine of x. And then I'm going to bring the 3 over so it's equal to 0 and see if I can factor. So I'm going to get cosine of x and cosine of x. and I'll go plus 3 and plus 1 equal to 0. So we have two factors here. So it's going to be cosine of x plus 1 is equal to 0, and cosine of x plus 3 is equal to 0. So can you guys tell me where cosine of x is negative 1? Where does that happen? Anybody? Yeah, it's at pi. So we see that x here is going to be equal to pi. Now, because there's no restriction, I can add plus 2 pi k. And the reason I don't have to put minus is because since k is an integer, it can be a positive 1 or a negative 1, a positive 2 or a negative 2, and so that's why we get that. So our answer is pi plus 2 pi k. Now on the other side, I'm going to get cosine of x is equal to a negative 3. When does that happen? That's right. This one here never happens. Not for us in the unit circle. If we had a bigger circle, that'd be possible, but not in the unit circle. Okay, good. Good. All right. All right, so here we go with this one here. We have sine and cosine, so we're finding all solutions. So that's a big deal, since we're going after finding all solutions. That means we're again going to have the pi plus 2 pi k or plus pi on it, right? So the first thing that we need to do is we need to change things in terms of sine to cosine. So that's going to become 2 1 minus cosine squared theta minus cosine theta is equal to 1. So I'll get 2 minus 2 cosine squared theta minus cosine theta is equal to 1. Well, I don't like negatives, so I'm going to move everything, and I'm going to get 0 is equal to 2 cosine squared theta plus cosine theta minus 1. Do you guys agree with that? Just want to make sure that you guys are following. Okay, cool. So then from there we can factor. So 0 is equal to 2 cosine of theta. And here's cosine of theta. And 1 and 1. And since it's positive, that's positive and that's minus. So our two factors are going to be 2 cosine of theta minus 1 is equal to 0. And cosine of theta plus 1 is equal to 0. So 2 cosine of theta is equal to 1. So cosine of theta is equal to 1/2. And where does that happen? It happens at two spots, right? So theta is pi over 3. And theta is also 5 pi over 3. But because we want all solutions, we need to add 2 pi k to each one of these, right? because if we look at it in the unit circle, and I'll just draw it over here, isn't it happening right here and here? So this one's going to have full circles to get there. And this one's going to have its own full circles to get there. And so they have to have different solutions. Does that make sense to you guys? Okay, cool. Just making sure you guys got that. Okay, on the other side, on the other side, cosine of theta is equal to a -1. So then theta then is going to be pi, right? But again, we can go circle and circle and circle, so we have to add the 2 pi k. That's the crux to this, okay? All right, you know what? I think what I'll do is, after I do 30, I'll stop, because I want to give you guys time to be able to do the quiz. Even though you can take till midnight, I want to be able to give you guys time for the quiz on note 7. And I usually give you time during class, so I'm going to give you that time during class if you guys want to start it now. But no restriction, you can do it till midnight. Does that make sense? Okay. Let me do this last one and then we'll go from there. Now, again, the cotangent isn't the same as the cosecant, so I'm going to have to change that. And the rule for that, the identity, is cosecant squared theta is equal to cotangent squared theta plus 1. So then that tells me that cotangent squared theta is equal to cosecant squared theta minus 1. Okay, so then I'm going to rewrite that to be cosecant squared theta minus 1 minus 2 cosecant theta is equal to a -1. Now, adding 1 to both sides, I'm going to end up with cosecant squared theta minus 2 cosecant theta is equal to 0. So I can factor out a cosecant. And so I'm going to get cosecant theta minus 2. And so factoring each cosecant of theta is equal to 0, and cosecant of theta minus 2 is equal to 0. So here, remember that's 1 over sine of theta is equal to 0. When does that happen? We know that to be never, right? We cannot make that 0. On the other side, cosecant of theta is equal to 2. That's the same as 1 over sine of theta is equal to 2, or sine of theta is equal to 1/2. And that's going to happen at 2 positions, right? So my theta is going to be equal to pi over 6, or my theta is going to be equal to 5 pi over 6. But again, we need to add plus 2 pi k to each one of them. Are we okay with that? Yeah? Okay. I will stop here for today, and then I'll let you guys go ahead and take the quiz online, okay? I'll go right now and set it up and open it so it's available, and then we'll finish notes 8 on Thursday, all right? Okay, perfect. Then I'll go set that up for you guys, and be safe, stay healthy. we'll get to see each other sometime soon, I hope. All right. All the best. Take care.